My name is Manitai, and this is the video portion of my exam. We learned last week a little bit about starches, so I figured I'd work with that. To start off, I'll explain a little bit about this carbohydrate and where it comes from, as well as what it's made up of. So to begin, it's found in seeds, fruit, roots, wheat, rice, as well as many other different kinds of sources. And in general, it's a polysaccharide made up of glucose units. Two of the main molecules, as we learned in our PowerPoint, that make up the starch are amylose and amylopectin. Amylose is the lesser of the two in proportion, making up only about 20 to 30% of the entire structure. So these ones are the long chain-like molecules that I'm sure a lot of you guys, or well, you, because you put it together, that you remember from the PowerPoint. So these ones are kind of springy looking, and then they're also a little bit resistant to digestion in comparison with the amylopectin. And the function of the amylose in the kitchen is to be used as a thickener, a water binder, an emulsion stabilizer, and a gelling agent. So this portion is actually insoluble. And in general, we'll see that starch in general is also as a whole insoluble, which I thought was interesting because this part that's insoluble only makes up 20 to 30% of the whole structure. So it was interesting to me to learn that the more dominant part didn't take over and cause it to be soluble. So next we're going to move on to the amylopectin, and this is the other more abundant starch portion of the starch, which is going to take up about 70 to 80% of the molecule structure. And this is the one that's considered branched, which is interesting to note because, like I said before, this part is actually soluble. So, like I said, this molecule is branched, and the other one is a little bit more like a chain-like structure. So, one slide in particular that I remember reading about mentioned the iodine test, which I thought was really cool, and it was something that I thought I might want to try on my own. So that's what I'm going to demonstrate next. And to give you a little bit of background on the iodine, the reason why it does, or we hope it's going to do what it's supposed to do, is because the iodine molecules fit nicely within the helical structure of the amylose, which results in a binding with the starch and resulting in an absorption of the wavelengths of light, which causes it to become blue, because iodine's kind of a gross looking brown color, like brownish yellow. So it's interesting that it turns out to be blue. So that's what's supposed to happen, is that it's supposed to, the wavelengths of color are supposed to get absorbed by the starch, and then it projects out this blue color. So that's what we hope we're going to see. And in this sense, a lot of the time starch can be used as a marker in the laboratory. So like if they're tracing something into your system, they can a lot of the times use the iodine and starch in order to follow it through. And this is what I'm going to demonstrate with my next product. So let's get started.